SpaceX has officially revealed the complete timeline for Starship Flight 11, and it's turning out to be one of the most technically advanced missions in the entire Starship program. The launch is currently scheduled for October 13th at exactly 6:15 p.m. Central Time from the Starbase launch site in Boca Chica, Texas. What's fascinating is the symbolism behind the date. It's exactly 1 year after Flight 5, the first Starship test where the upper stage completed a full duration burn and reached near orbital velocity. This deliberate timing seems to be SpaceX's way of connecting two milestones: the moment they proved Starship could reach space, and now the moment they'll attempt to refine both booster recovery and upper stage reentry in one coordinated flight. This flight isn't just another test, it's a crucial data-gathering mission packed with upgrades. The liftoff time, 6:15 p.m. CST, has been chosen carefully so that both the Super Heavy booster and the Starship upper stage perform their re-entry and landing phases in daylight. That ensures every key moment is captured in high clarity by tracking cameras and sensors, from engine ignition and plume expansion to booster grid fin movement and tile heating during atmospheric reentry. Daylight flights mean higher quality video and thermal data, helping SpaceX refine everything from engine startup sequencing to aerodynamic flap control. The countdown for Flight 11 begins well before ignition. At T-minus 75 minutes, the flight director gives the formal command for propellant loading. This is when the sheer scale of Starship becomes visible. Roughly 3,400 metric tons of liquid oxygen and 1,200 metric tons of liquid methane are pumped into the rocket's tanks. The entire process is a cryogenic ballet. Temperatures drop below minus 180 degrees Celsius. Frost builds up on the steel hull, and white plumes of vapor surround the launch mount. The full stack, standing 397 feet tall, 121 meters, dwarfs even NASA's Saturn V, making it the tallest and most powerful rocket ever built. At T-minus 3 seconds, the launch sequence reaches its peak intensity. The Super Heavy booster, D-15, not Booster 14, ignites its 33 Raptor engines nearly simultaneously, generating approximately 16.7 million pounds of thrust, or 7,590 metric tons, nearly double the thrust of NASA's Space Launch System. Each Raptor engine, operating on a full-flow staged combustion cycle with liquid methane and oxygen, achieves a specific impulse of about 330 seconds at sea level. The Starship rocket lifts off from Starbase, Texas with a thunderous roar, surpassing Mach 1 in under 50 seconds and reaching Max Q, the point of maximum aerodynamic pressure, around T plus 62 seconds. At approximately T plus 2 minutes and 40 seconds, stage separation occurs, a critical phase of the flight. Flight 11 will utilize a hot staging ring, enabling the upper stage, Ship 38, to ignite its Raptor engines while briefly connected to the booster, improving efficiency and minimizing separation time. The hot staging mechanism, refined after Flight 10, incorporates an enhanced flame shield to reduce engine plume interference and heat stress on the booster. Contrary to the original description, Booster 15 will not attempt a catch with the Mechazilla tower arms during Flight 11. Instead, SpaceX has planned a controlled splashdown in the Gulf of Mexico near the launch site. Following separation, B-15 will perform a flip maneuver and execute a boost back burn to slow its descent. The booster will re-enter the atmosphere at approximately Mach 2, guided by its 4 titanium grid fins and cold gas thrusters. SpaceX will collect data on fin torque loads, descent stability, and a new 5-engine landing burn configuration to enhance redundancy for future version 3 Super Heavy boosters. Meanwhile, the upper stage, Ship 38, will deploy 8 Starlink satellite simulators, conduct an in-space Raptor engine relight, and perform a dynamic banking maneuver to simulate future return to launch site trajectories. Ship 38 will conclude its mission in a splashdown in the Indian Ocean.
Meanwhile, the upper stage, Ship 30, will continue firing its 6 Raptor vacuum engines for about 6 minutes, accelerating toward orbital velocity near 17,000 miles per hour or 27,300 kilometers per hour. After reaching peak altitude, Starship will coast before beginning its fiery re-entry sequence. This part of the test will focus on the new heat shield tile configuration, featuring improved insulation and mounting methods to prevent tile loss under high G loads. Re-entry heating can exceed 1400 degrees Celsius or 2500 degrees Fahrenheit, generating a plasma glow around the vehicle, a scene that might once again go viral like Flight 10's breathtaking footage. During re-entry, onboard sensors will measure aerodynamic pressure, temperature gradients, and structural stress at over 7 Gs of deceleration. The flaps, powered by Tesla-derived actuators, will control the vehicle's fall and orientation before the final engine relight for landing. Every bit of this data is crucial for future crewed Starship missions to the Moon and Mars. If all goes according to plan, both the booster and the ship could achieve soft recovery targets, potentially marking the first time SpaceX brings both stages back under controlled descent in the same test. It would be a landmark achievement in the history of reusable rocketry, demonstrating not just power, but precision. With just days to go, Starbase is once again in full motion. The tanks are being filled, the Raptors are ready, and engineers are preparing for another leap forward. On October 13th, all eyes will be on the Texas coast as SpaceX pushes humanity one step closer to fully reusable spaceflight. The countdown has already begun, and Flight 11 might just redefine what's possible.